Hey, this is Mr. Aiden. We're back in Unit 5, Analytical Applications of Differentiation, and we're doing the first derivative test. Here we go, first derivative test. What is the first derivative test? If the derivative of a function changes signs around a critical point, the function is said to have a local, or what we call a relative extremum, either a local min or local max. So if the derivative, or otherwise known as the derivative, changes from, that's called a typo, from positive to negative, it's a local max. So if it goes from positive to negative, it's a local max. If it goes from negative to positive, it's a local min. And this will make sense, hopefully, in a little bit. So let's take a look at a function. We're going to try to apply this first derivative test. Let's start with this one. Find the local min and max of our function y equals x cubed minus 12x. Okay, so what do we want to do? We want to take that first derivative, and we have 3x squared minus 12. Okay, we always set that equal to 0, which means I'm going to factor out a 3. So 3 times x squared minus 4 is equal to 0, which means I have possible critical values at x is equal to 2 and x is equal to negative 2. Those are my possible critical values, which means those are where I could have local mins or local maxes. Okay, local mins or local maxes. Now, of course, if I wanted to plug this back in, I very readily could. And I could find out my y values for this. Okay, if I plug it back in my original function, then I get f of 2 is equal to 2 to the third power minus 12 times 2, which is negative 16. And I get f of negative 2, which ends up giving me positive 16. Okay, when I plug that in my original function. Now, if we think about these two values here, okay, these are my two critical values. So x is equal to negative 2, x is equal to positive 2. Okay, so let's plug in, let's say, something in between, like x is equal to 0. Okay, 0 cubed minus 12 times 0. Okay, sorry. Let's plug that in my first derivative. Okay, so we got 3 times 0 squared minus 12. That gives me a negative value. Now, let's say we're bigger than 2. Let's say we're like 3. So 3 squared is 9. 9 times 3 is 27. 27 minus 12. We're going to get a positive value. And let's plug in a number lower than negative 2. So negative 3. So negative 3 squared is 9. 9 times 3 is 27. 27 minus 12 is a positive value. So you see how all I did was I found my critical values of x is equal to negative 2, x is equal to positive 2. I plugged in numbers into that derivative. Okay, into that derivative, and I found that that number would be positive, and this number would be negative, and this number would be positive. Okay, so what does that mean? If we come back here, if we're changing from positive to negative, that's a local maximum. So that means at x is equal to negative 2, we call that a local maximum. Okay. If we go from negative to positive, we call that a local minimum. So this is a local minimum. Okay? And you might say, Aiden, why didn't we just plug this into my original value? I could find out that, of course, this is at f of negative 2. F of negative 2 is equal to 16. That's a big number. Of course, that's going to be my max. My f of positive 2 is going to be negative 16. That's, of course, going to be a local min. That's going to be down at the bottom. Well, this is called the first derivative test for a reason. We're using our first derivative. So here's this function right here, x cubed minus 12x. And as you can see, we have a local maximum right here. Now, what does it mean going from positive to negative gives you a local maximum? Well, look at all the slopes over here. All the slopes are positive, 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 positive. Slope is 0. And then into the negative. So if I kind of zoom in on this, positive slopes all the way up to this critical value, which the slope is 0, and then all the slopes end up becoming negative. That means we have a local max. And why do we have a local min at this point, other than it reaches negative 16, is see how the slopes of all my lines are negative, and then it switches over to all my slopes are positive, which means that's going to be a minimum value because the slopes of the lines come from the first derivative. All right, let's go through another problem of the first derivative test. We're going to find the local mins and maxes of this function y is equal to x to the fourth plus 2x to the third minus 2x squared plus 1. So what's the first thing we're going to do? We're going to take the derivative using the power rule. 4x cubed plus 6x squared minus 4x plus 0. And so what do we want to do? We want to factor out, let's factor out a 2 and an x while we're at it. So we got 2x squared plus 3x minus 2. And so we want to do 2x. We're going to do x. We're going to do, let's see, plus 2 and negative 1. Plus 2 and negative 1. So guess what? I know my critical values, don't I? I know my critical points are x is equal to 0. We know x is equal to 1/2. And last but not least, x is equal to negative 2. Okay, so these are my critical values. X is equal to negative 2, x is equal to 0, and x is equal to 1/2. So doing the first derivative test, we want to figure out whether these are local mins or maxes. So let's plug in a number less than negative 2. Okay, so the nice thing is I have this nice derivative. I'm going to plug this in the first derivative, not in my original, in my first derivative. So 2 times negative 3 is negative 6. 2 times negative 3 is negative 6 minus 1, that's negative 7. And we got negative 3, we got negative, which means that's going to be a negative value. That means my slopes are all going down, right? Now let's plug in negative 1 into my derivative. Okay, so I'm going to take my negative 1. I get 2 times negative 1 is negative 2. 2 times negative 1 is negative 2 minus 1 is negative 3. I get negative 1 plus, that's 1. We got 2 negatives multiplied together. That gives me a positive value, which means, guess what? My graph is going to go back up. That means I have a local minimum right here at x is equal to negative 2. Let's plug in a value like 1/4, positive 1/4. Well, positive 1/4, we're going to get a positive value. We got 2 times 1/4, 2 times 1/4, times 2 times 1/4 minus 1, times 2 1/4, 2.25. And that ends up giving me a negative value right there. Which means what's going to happen is my values, my slopes are all going up, and then guess what? They start going back down, which means I have a local maximum right here at x is equal to 0, a local maximum. Now let's put in a number bigger than 1. So we have 2 times 1 is 2. 2 times 1 minus 1, that's going to be 1. And we have 3. Those are all positive, which means guess what? Now we have all positives, which means anything bigger is going to keep going back up. And so guess what? I have another local min. Another local min, which means I got a local minimum at negative 2, and at 1/2 I got a local max at x is equal to 0. Let's see if this is true. What do you know? This is our graph of our function, and you can see at negative 2 we're going from negative slopes to positive slopes. We have a local minimum. Actually, it's the absolute minimum. Then we have a local maximum right here because we have positive slopes going into negative slopes. And you can see then we have negative slopes going into positive slopes. And you can see that is what we have for our function. If we looked at our derivative here, and I'm going to graph our derivative, we have 4x cubed. Let's do a cubed here. I keep doing to the 4th power. 4x cubed plus 6x squared minus 4x. And what do you know? Take a look at what happens here. Do you see how we are at 0, which means a 0 slope in my blue graph? And you can see it's going from negative values to positive values. That means a local minimum. You can see right here where we end up getting, we cross the x-axis at 0 here. That's where we have a local maximum because we're going from positive values to negative values. You can see back to negative values to positive values, another local minimum again. And so that is the first derivative test. Bottom line, you got your function, take your first derivative, set it equal to 0, find out what you got. Always do it. Don't think twice. Just do it. See you guys. Bye.